So we did some of this in the first video. In this video, we're going to work exactly with multiplying and dividing, but this time we're going to start using some x's and things like that. Variables, that's what those are called. Couldn't think right now. All right, so just jumping right in. Writing an inequality that represents all values of x for which the product is defined. So now, for square roots, just remember, if we have the square root of a negative number, that's when it's imaginary. So I just want a square root of a positive number. So what that means is this 7x, that needs to be greater than or equal to 0 so that we can actually define the square root. This x plus 5, we need to be taking the square root of positive numbers, so we need to be greater than or equal to 0. So then if I solve both of these things, divide by 7, so then x needs to be greater than or equal to 0. But if I subtract 5 minus 5, x needs to be greater than or equal to negative 5. So it needs to work in both of them. So the one that I choose here, the one that's actually my answer, is this one where it's greater than or equal to 0. I need that part. Yeah, that includes more values, but if I go less than 0, then it will not work for this square root. Like if I chose negative 1, which says that it's okay with that, negative 1 is greater than negative 5, but it doesn't work in this left-hand one. You got to make sure that it works in both of your square roots. So that one is the only solution. This one was just to help me make sure that I was finding my perfect solution. All right, so with part B, again, I need to take the square root of a positive number, so 6x needs to be greater than or equal to 0. Also, this 21 minus x needs to be greater than or equal to 0. So now if I solve both of these things, x is greater than or equal to 0 if I divide by 6 and divide by 6. Now if I add the x over here, this is 21 is greater than or equal to x. So x is less than 21. So what that means here is that x needs to be greater than or equal to 0 and x needs to be less than or equal to 21. This could also be written as from 0 to 21 in interval notation, we have solutions. Has to be less than 21, has to be greater than 0. All right, moving on. So with this one, x plus 3 needs to be greater than or equal to 0. Likewise, x minus 6 needs to be greater than or equal to 0. So if I do x is greater than or equal to negative 3 and x is greater than or equal to 6, the one that is the most restrictive is this one over here. I need to be greater than 6. Yes, for this part, I can be less than 6, but here it would not work. So if I chose 0, right, 0 is greater than or equal to negative 3, but it has 0 minus 6, that would create an imaginary number, so I need this one that only works for both of them. All right, now we're going to actually determine the product. So we're just going to write it out. We're not just, words, can't talk. We're not stating the restrictions, we're just stating what the product would be. So remember, I'm just multiplying the insides together. So this would turn into the square root of 3x times x minus 4. Right? And then we would distribute the 3x to both terms. So this would be the square root of 3x squared minus 12x. That is how you will see your answers on Apex. All right. Same way with part B here. So I'll do the square root of x plus 3 times x minus 4. Multiply these things out and combine like terms. So it'll give me x squared minus x minus 12. And that would be our solution. All right. Likewise, and simplify these if they simplify. So with this one, I would have 60 x to the 5th if I multiply those together. So now check it out. With that 60, let's see, the biggest thing I can take out, if I think about my square root 4, square root 9, 9 doesn't divide in, 16 doesn't divide in, 25 doesn't divide in, the next one would be 49, and then we're starting to get too big. So it looks like the biggest one of these that works is square root 4. So square root 4 times, what would that be, 30, 15? So 15, right, that's what 60 is, 4 times 15. So I have a 2 on the outside, and I'll leave a root 15. So now thinking about the x's, what's going to happen with the x's? So we have 5 altogether, 5 x's. And I am taking out 2 at a time because it's a square root. So what's going to happen is I have one group of 2 that I can take out. Stay together, fingers. I have another group of 2 that I can take out. So what is happening is I can take out 2 squares of x squared. so that I would be left with 1 on the inside. So this would be x squared and then x left on the inside. That didn't make sense. Let's see if we can write it a different way. So x to the 5th is represented by x squared times x squared times x. All right, we have two perfect sets with 1 left over. These are all still under the square root, so I can pull out 2 of them. That's why my exponent is 2 on the outside, and I still have 1 left on the inside. We're going to do another one as well. All right, so with this one, I have 5 times 15. Now, like I said in the last video, I like to break down this into 3 times 5, because then I see I have 5 and 5, so I know I'll have 5 on the outside. That 3 is left alone because I didn't use them, so I'll leave a 3 on the inside. Now with the x's, these will multiply to be the square root of x to the 10th. Remember, they add. So if I divide 10 by 2, since I'm taking the square root, 10 divided by 2 is 5, so I can pull out 5 with no remainder, so I have no x's left on the inside. That's it. All right, moving on. With part E, multiply straight across. So I would have square root of 5x to the 4th over 15x squared, and then reduce as much as you can. So that would give me 5 over 15 is 1 over 3, still under the square root. X to the 4th over x squared would give me x squared. So if I have the square root of x squared, that just gives me x, so this would be x over root 3. Now remember, in that last one we talked about rationalizing. So if I multiply by the square root, top and bottom, this will give me x root 3 over root 9, which is the same thing as x root 3 over 3. That may be how they write their answer. They could also leave it like this, but I think they rationalize, I'm pretty sure. All right, moving on. With f, so I have 2x squared over 16x squared, multiplying the top and bottom straight across. 2x squared, 16x squared. Then reduce. So I have 1 over 8. X squared divided by x squared makes nothing, so I have the square root of 1 over 8. And now I have the square root of 1 is 1. I don't know the square root of 8, so I'll leave it as the square root of 8. If I multiply by root 8 and root 8, this will give me root 8 over square root 64, which is root 8 over 8. And then this square root of 8 will actually simplify as well, because this is the square root of 4 times the square root of 2. Square root of 4 is 2, so this gives me 2 root 2 over 8. 2 over 8 will simplify, so this becomes root 2 over 4. That would be your final solution. Remember, you guys have a calculator as well, so you can always check this in the calculator to make sure you're simplifying this right. All right, moving on. Still multiplying. So here, it's going to get a little bit funky, but I'm just distributing everything to everything. So square root of x times square root of x, this is square root of x squared, and then plus 4 root x minus 3 root x, and then minus 12. So now the square root of x squared, remember that can be just x. Now check out these. We're going to talk about this more in the next one as well. But if they have the same square root, those are considered like terms. So I have plus 4 minus 3 would give me plus square root x, plus 1 root x, because 4 minus 3 is 1. And then I would just have that minus 12 right there. That would be how those multiply together and simplify. All right, now, same sort of idea. So we're going to do another. Square root of x times square root of x, square root of x squared. Root x times 7 is plus 7 root x. Negative 3 times root x is minus 3 root x. And then negative 3 times 7 is minus 21. Square root of x squared is just x. 7 minus 3 is positive 4. And then minus 21. That would be how I want to see the answer. All right, write an inequality that represents all values of x for which the quotient is defined. So now with quotients, don't forget that this is really division, right? We have a division sign there. So this is the square root of 3x squared over the square root of 5x. So now you guys have to remember you cannot divide by 0. No dividing by 0, not possible. So we kind of have two restrictions going on here. We have the first being we cannot divide by 0. We also have that we have to take the square root of positive numbers. So what that means 3x squared has to be greater than or equal to 0, right? I have to be taking the square root of a positive number. This 5x has to be strictly greater than 0. It cannot be equal to 0 because you cannot divide by 0. So, with that being the case, if I were to solve both of these, divide by 3, take the square root, x has to be greater than or equal to 0. Divide by 5, x has to be greater than 0. This is the more restrictive domain. So this would be our answer for this one because we cannot be equal to 0. Again, you cannot be equal to 0 because you cannot divide by 0. So just pay attention to what you are dividing by. Likewise, in this one, this 6x squared has to be greater than 0, but it cannot be equal because we're dividing by that. Also, this 2 times x minus 2 has to be greater than or equal to 0. So let's see which one is more restrictive. So if I divide by 2, this is x minus 2 greater than or equal to 0. Then if I add the 2, x is greater than or equal to 2. Here if I divide by 6, then I have x squared is greater than 0. Take the square root, x is greater than 0. So the one that is most restrictive is the one that's saying it's only the values greater than 2. So notice, this one is fine because I can put in 1, I could put in 3, except 1 wouldn't work here, right, because of this part. So this only works when the x values are greater than or equal to 2. Those are the only parts that are fine. All right, moving on. Again, so pay attention. Maybe do the one with division first, because 7 minus x has to be greater than 0. It cannot be equal because you cannot divide by 0, right? Add the x over, so x is less than 7. So now I have x plus 5 is greater than or equal to 0. So subtract that 5, x is greater than or equal to negative 5. So there's another one like we had in the earlier one, where it's between negative 5 and 7, because x has to be greater than negative 5, and it has to be less than 7. I wrote it the wrong way. So we could be going from negative 5 to 7 if it were written in interval notation. All right, moving on to our next one. Again, you may want to do this part first, so that 9 plus x has to be greater than 0. Cannot be equal because you cannot divide by 0. 3 minus x has to be greater than or equal to 0, because that's the number up top, so that's fine if it is equal to 0. And then I would just add the x over, so 3 greater than or equal to x, and I would subtract the 9, so x greater than negative 9. So again, this is another one. X is less than or equal to 3, and x is greater than negative 9. So we're going from negative 9 to 3 if I were to write it in interval notation. All right, moving on now to simplifying the quotient. So we've done a little bit of this in the previous video as well. So just simplifying, square root 11x squared over square root 7x. This would be the same thing as 11x squared over 7x. So notice the x's divide here, but I'm still going to have a square root of 7 on the bottom. So I will have root 11x over 7. Now to get rid of that square root in the denominator, remember what we can do is multiply by the same square root that we have, such that this would make the root 49 in the denominator, which we know is 7, and square root 77x. So now I'll have root 77x over 7. That will be our solution. Alrighty, moving on. So we have here 16 x plus 1 over root 32 times x plus 1 squared. So now here, go ahead and reduce. X plus 1 squared and x plus 1, one of these will divide out, so we're going to have an x plus 1 in the denominator. 16 over 32 will reduce to 1 over 2. So right now what we're looking at is the square root of 1, which is 1, over 2 square root of 2 times x plus 1. So it's an ugly denominator, but we can still rationalize with it. So what I would do is I would multiply by that square root in the top and on the bottom, so that this would give me square root 2 times x plus 1 over, this would just make 2 times x plus 1. Now I've rationalized the denominator and simplified my division. All right, that's probably the hardest one that we're going to be doing. It'll get simpler from here. So for this one, we have root 16x cubed over root 2x. This one's pretty nice because the 16 over 2 will reduce to 8 over 1, and the x cubed over x will reduce to x squared because I can divide out one of the x's there. So what we're left with, since we know the square root of 1 is 1, is we just have the square root of 8x squared over 1. So really it's just 8x squared, the square root of that. So don't forget 8. We can make square root of 4 times the square root of 2. Square root of 4 is 2, and then I'm going to leave that root 2. And then the square root of x squared, since I have 2 x's, I can pull one out so that I have 2x root 2. All right, part D. So again, I'm going to write this out, 27x over root 48. So then 27 over 48, those are both divisible by 3. So that would give me 9 over 16, which doesn't do any more. So go ahead and divide those. And that'll give me root 9x over root 16. Well, hey, that's pretty nice, because then I just have 3 square root of x. Notice that x is all alone, so I have to leave them inside the square root. And then the square root of 16 is 4, so 3 root x over 4. All right, that's it for this one. Hopefully this video was helpful for you guys. Again, please, please, please let me know what questions I can answer for you. Hopefully this monkey gives you courage to keep going on. You're almost done. You're like halfway through the B semester. Bring it. All right, talk to you guys soon. Bye.